Hello, everybody, and welcome to Sparring Partners. Today we're going to talk about a really cool topic. I really like it. Is the digital twins, and this is because it brings sort of a touch of humanity to the whole AI thing. You know, you think about the twin, this kind of having fun in the background kind of thing. So I think it's a really interesting topic, but besides, it's actually a very conceptually, it's a very interesting way to use AI. And on the podcast, we've been talking a lot about AI, and AI is not just one thing. It's actually it's a tool that is used in very many different ways depending on what you're trying to do. So what we're going to talk about today, or at least that's the plan, because always in the podcast you never know where you end up going, is to talk about, okay, what are digital twins and how can they actually help us? Because, okay, the concept sounds cool, but what is that where is it they can actually help us in a practical way? And I'm going to talk about this with Chris Murphy, who is the regional CTO for the EMEA region at VIAVI Solutions. And prior to that, I've done a longer sparring partners with Sameh Yamani, who's also not by chance at VIAVI Solutions, because VIAVI has been doing a lot of work on digital twins so far. And so you can listen to that one also for broader reference. However, what we're going to talk to, and the reason why I'm talking with this to Chris is because he really has the experience of working with digital twins, which is now relatively rare because it's a new thing. So we talk a lot about it, but we are still moving our first steps in learning how to actually use them to our advantage. So I have someone with really hands-on experience, so to say. So Chris, welcome to Sparring Partners.
Thank you, Monica.
And we've known each other for a long time, but some people in the audience might not know you. So why don't you tell us who you are and what you do and how digital twins fit into your life, or your work, I should say. Over your life,
Indeed.
whatever works better for you.
So I've had a long career in telecoms so far, and a lot of that's been working with data and what can the data do for us to help us to deliver more optimal networks, better experience for the customers, and more efficient use of the resources. And this goes all the way back to 2G days. I was working with data to build models to support the optimization of some particularly American CDMA systems in the 2G days, and then taking this forward all the way through the generations now on 5G, and the industry starting to look to 6G. But even before that, I was using data in I did a PhD monitoring sea level change using satellites, and that needed data to be collected from the satellite instruments and to be modeled and managed so we could calibrate these instruments. And then when I finished my PhD, I went to work in a university modeling the human respiratory system, basically building a model of the respiratory system so we could answer clinical what if questions of the respiratory system when you had a patient on in intensive care on a respirator, for example. So all the way through my career, I've been looking at how we can use data, how we can use models, bring these together to answer some interesting questions and solve some engineering challenges. So that's been the theme throughout my career.
Well, and this is very interesting because, I guess it was an expert system, the medical thing, right? And it is really like a precursor of what we're doing today. And so now we call it AI, we call it digital twin, but there is a lot of, all those things didn't come out of thin air. They just come through, decades of research. And so having that kind of background, and I'm part of that too, it's really helpful in understanding some of the, how can I say, not only the possibility, but some of the challenges, because I'm sure that when you were doing your research, you were most of the time frustrated, like, you have all this data, but that doesn't work. That's real life. And so now you know better. And so maybe we can, and we're gonna get into that part, that how do you get real data to move it. But okay, so let's just, for people that have not listened to the previous conversation with Sameh. Okay, let's just quickly say, what are digital twins, and why should we care about that?
Well, that's a big question. I shall try and answer it fairly quickly. A digital twin is, at its highest level, a digital replica of a physical system or entity. So it can be, in the context here, we're interested in telecommunications and wireless communications. So if you can build a model of your RAN or core, your transport network, different components, so maybe the subscribers of the network, and how these interact with each other, then that's a very powerful enabler for all sorts of use cases from at different stages of the network life cycle to deliver many outcomes from management to optimization to training to securing the network from inadvertent mistakes. And there's many use cases that you can achieve with this if we can build these digital twins.
Yeah, especially as you were saying this, I realized that so part of my background is philosophy, and that would be a possible world, which is something that there's a huge literature on that. And but I guess that, from a philosophy point of view, you think of a possible world like, this kind of aspirational thing. But in telecoms or in technology or in sort of more concrete life, a digital twin is like, gives you, like, it's a more kind of real thing than a possible world like it doesn't exist. But it is the same thing. You basically duplicate something and see
Yes,
how things could be different if we did something else, right?
absolutely, yes. So it is a real thing. It is an entity
Yeah,
you're modeling, but but you can say, what would happen if I did this? So
yeah.
to say, is this going to make the network perform better, or is this how susceptible is the
Mhm.
network to this particular potential risk to the network?
Yeah.
For example, let me simulate losing some infrastructure or losing some connection, or
Mhm.
having more demand on the network in a particular location or for a particular application, and understanding the impacts of on the network, how it responds, what the performance KPIs would be after that impact. And it's a very powerful what if scenario modeler.
Yes, and it's much more sort of rigorous. So, like, we probably do it all the time. We run it in our mind. You're trying to do something new in the network. Say, okay, but what happens if this happened? But clearly, we just think in a cursory way. It's just like, yeah, fine, that's okay. With a digital twin, you can actually explore the implications in detail. Now, just in the same way that when you do it in your mind, what is crucial is that you ask the right questions and you start with the right data. Because if I ask, oh, what if everything fails? It's probably too generic. You want to test specific things, and also you want to see things you didn't know about. So you want the model to tell you, the digital to tell you, you didn't think about this, but that could happen. And that actually is more valuable, because it's not what you say, what happens if something goes wrong, but the model can tell you, by the way, something can go wrong that you have not thought about it. So it's helpful not only in exploring what if scenario, but also in creating, so to say, a what if scenario. But before we get there, we need to get the right data, because if you don't have the right data, the digital twin is going to be completely useless, because it doesn't ask the what if question on reality, so to say.
Yes, data is generally critical. I mean, many digital twins that are in a discussion or actually exist now are built on machine learning models, but they don't need to be. They can be based on analytical models or empirical models. But generally, we need to understand the network so that either we can train the models or feed the data in for the analytical models or empirical models to get the answer out. And this is the key, because the networks are becoming so much more complex now. We do need to be careful about what data we collect from them in order to understand them, in order to model them, in order to train models. And so, yeah, we need to make sure we're not collecting more than we need, and there are strategies that we can use to address that. For example, if we can take the model to the data rather than bringing the data to the model, that can be a way of avoiding stressing the transport networks to centralize data, and that can also have positive implications for privacy and security, because particularly at the edge of the network, the data about the network and how it's operating and how the subscribers are using it could be quite sensitive to the individual, and so keeping that data where it lives rather than gathering it into a central location can give us an advantage in terms of security. Another strategy you can have is to collect data when things are different. If things show an anomaly, then that's an interesting thing. If things are behaving as they normally do, that's of less interest. We can model the normal and then understand and respond to anomalies as and when they occur, and then we just need to understand those anomalies as they occur. So yeah, but data is at the heart of it, and particularly as networks become more sophisticated, we compare the networks today in 5G world with all of the different ways of increasing capacity, new technologies, different carriers that need to interact with each other, different network layers, from different radio frequencies, and maybe integration of non-terrestrial networks, terrestrial networks, advanced MIMO schemes, massive MIMO, multi-user MIMO, and the decisions that need to be taken with those, as well as how to manage mobility in terms of traffic steering and handover management and the handover parameters. There's so many things that need to work that need to work together in harmony. That's having models for these how these things work opens up a lot of doors at all stages of the network lifecycle.
Yeah, and from what you said, it's like, okay, I'm gonna take the last one, the traffic management, but basically there is no point building a digital twin of the whole network. I mean, because it would just be incredibly complex, and maybe you think I'm wrong, but if you just say, okay, let's just focus on something and let's optimize that, whatever you need to do on that domain. So if you take traffic management, okay, let's just look at that. But and maybe you can use some other example here. But how do I know how detailed do I need to be for it to be useful? And I guess that there is no single answer, but the answer depends on what kind of issue, what kind of thing I'm trying to find out. So a digital twin is just as good as I'm asking the sort of the right question and I'm at the right depth, because if it's too detailed, it's just going to get lost, and I'm going to get more detail than the guidance that I get is not helpful enough. I mean, it's sort of too detailed to be helpful. If it's too generic, it's just going to tell me something that I already knew. So it just seems like it's more of an art than a science here. How should we think about it?
In some ways, yeah. Well, I think so. A digital twin isn't going to be a panacea for every problem you might possibly have. So you do need to be clear about the problem you're trying to solve and whether a digital twin can solve it and how it can solve it for you. And so we can think about how we model the network and the data we need from the network. And at a basic level, we could understand where the radios are, for example, and how they're configured and where they're pointing and what directions and what antennas they are, the locations. And we can think about the logical topology of that network over what's the connections, what are the carriers mapping to the physical antennas, and those sorts of characteristics. Then we can think about the propagation and the channel environment for that network, and then how the network functions behave. How are the subscribers behaving? Where do they want where do they go? How do they move? What are their movement patterns as that changes? And what services do they want as they move around the network? And that's really the RAN and the users. And then you can add other aspects such as the transport and the core and maybe the applications on top of that. And depending on what you're trying to do, whether it's understand at the planning stage how resilient your plan will be to various impairments, or at the operational stage and you actually want to perform some optimization and understand what the impact, positive or negative, would be on various performance metrics of a particular change or set of changes, that will determine how you need to build that digital twin and how sophisticated it will need to be. And also although in general it's better to have a more complete digital twin, more complete digital twins will be more costly in terms of operating them and evaluating a particular what if scenario. And that limits what you can then do with it, because many optimization strategies involve things like evolutionary algorithms, reinforcement learning, which need lots of evaluations in order to find the optimal strategy. So you don't want to be building something which is overly complex or overly costly to evaluate, depending on the use cases. So that's there's no one size fits all, that's for sure.
Yeah, and the nerd in me would, if I were to run digital twins, what I would do is that I would have so much fun with it, and I really think I would. And it's like, okay, oh, let's try this, and then what you do is that you just spend all your life in digital twin land, and you never get to do anything because there's always something better that you can do. You can always refine your analysis. So you don't want to spend too much time. So how should we think about it? And as you say, you don't want to model everything, and you don't want to model everything forever. So and again, there's no clear-cut answer here, but how should we think about at what point you say, okay, I've done enough? Or at what point you say, oh, hey, I need a digital twin here, because otherwise the risk that I'm going to introduce this change is too high. I need to make sure I'm not creating a problem rather than solving one.
So, good question. So I think there's a couple of answers here. So, I mean, sometimes the digital twin, it may not be something your or I interacts with. It may be something which lives in the network. And this is, there's a couple of research projects that we're part of, consortium projects within the European Union. And I mean, one of them is 6G Twin, where what we're asking is how can we bring a digital twin to the operational network to support delivery of use cases. And so the question is, I mean, particularly the use cases we're focusing on there are teleoperated driving and energy saving. So how can we use digital twin in a concrete way to deliver those use cases? So there are particular challenges with teleoperated driving. You need things like reliability, and you need to be able to assure that you've got a service. And energy saving is obviously a key to it's something that drives many of the outcomes that we seek in communication networks. So once we can put a digital twin into the network and it can support those use cases that we're delivering, then we know that we've done, as long as it can do it efficiently and reliably. And then there's another project that we're part of. Again, it's a European project called 6G DALI, which is about building a federated testbed and digital twin system for supporting research in 6G. And so that's why I mentioned that one is because we want to be able to be flexible in what we expose in the digital twin. So the digital twin, the applications are as wide as possible and complement what you can do with physical test beds, and create what we call a data space, which is something which has been adopted by other industries. But if we can create an API which is as flexible as possible, the idea, the ambition here is to be able to make a digital twin which can support everything from training models to generating data to reinforcement learning development in service of optimizing networks. So it's the ambition there is to create something as flexible as possible. But when it comes to the crunch, if you're actually running an optimization, if you're running a network, then there are specific use cases which you can use at the planning stage, when you're lab testing your components, when you're deploying your networks, and when you're operating your networks.
Absolutely. No, this is very interesting. So you can have sort of like a very temporary digital twin, like I want to try something, so you can have something really tiny, the tiny little digital twin, and
Yes.
then you can have all the way to something that lives there forever. Is the digital twin that goes with the network, so that it kind of provides this sort of alternative reality kind of thing that is,
Yeah.
okay, let's just see if I were doing things differently, what would happen. So if I were doing like a energy savings, if I were to change the parameters, this would actually be better. And you can let it run forever and then say, oh, look, there's something I could learn over there, right?
Yeah.
So that now.
Yeah, that's a really good point, actually, because if you, in some problems like energy saving or maybe coverage capacity optimization, for example, if you look over a large cluster of cells, you can potentially find some new configurations, maybe even hundreds of cells. We've gone up to that sort of size before. You can find solutions which deliver significantly different configurations from where you are today, and then deliver improvements in terms of the performance, the coverage, the capacity, the quality for the subscribers, as well as the energy usage across when you've got the degrees of freedom over hundreds of cells. But some cases, if you're just interested in how to tune your handover parameters, or how to manage other bilateral parameters between different individual cells, then you only need to have a really very focused approach, because it's really how do those two things interact together that you care about. So you don't need to have a big digital twin in that case. But then of course it does beg the question, well, all of these things have implications on each other. How I configure my larger clusters of cells will have implications on how I manage the relationships between them. So one view of the world might be that you take as large a view as you can afford to for all of these questions, and consider them together, because then you'll find the real global optimum for how these things can work together. But we're a long way from having a digital twin that would support that.
Yeah, I was just thinking that basically what you do with the digital, in the real model would just drive you to a local minima or maximum. Well, you just do a local optimization. But then when you have a digital twin, you can kind of shake things more vigorously, so you can find a global minimum or maximum, whatever.
Yeah.
So when you look at the search space, if you look at the energy, for instance, your model would just give you a small incremental changes, because the real model in the network has to be conservative to some extent, because you don't want to create too much change. But the digital twin can go wild.
Yes, yeah.
That's much more fun to live as a digital twin than to live in the network, right?
Yes, absolutely, yes. And if you're just stuck with a network in its condition as it is today, configured as it is today, then as an engineer looking at the network, I can see problems and I can make localized changes which might take me in a more optimal direction. But you're right, I'm going to end up probably in a local optimum. But if you can let rip with a digital twin, then you've got a much better hope of finding the global optimum. But that's not sufficient. You do need to have a sensible search algorithm. So you don't just do a greedy search, for example. You've got to be careful how you design that, and also be conscious that your larger scale digital twin is going to be more expensive computationally, and so you have to be parsimonious with how you evaluate individual configurations. And there were short circuits that we found that you can use a very sophisticated digital twin, and then you can use it to train another model, which then supports other use cases, which are where you can do very fast evaluations based on that high fidelity digital twin that you started with.
Yeah, so you don't want to put your digital twin on psychedelics, just a little, just a little.
Well, it might be.
Oh, maybe you won't. I don't know. Once in a while,
maybe that can inspire new search algorithms.
Yeah, but I guess you don't. I guess what you're saying is that you don't want to overdo it, because there is a cost to it, which is actually a general issue that we're starting to deal with AI in general. AI is expensive to run. So at what point, the cost of running it is so high that it's just not worth it anymore, because the marginal improvement is not high enough. And so I guess we need to, with digital twins as well, we need to kind of be mindful of, we don't know what the solution is, but we don't want to be doing too much of it. It can be too much of a good thing, because in terms of consumption, resources, internal efforts.
Yeah, I mean, I think we'll as the industry develops and as the expertise in digital twins becomes more embedded, then I think we'll see more and more examples of digital twin being used in the lab, and in the operational networks in all stages, and planning and all stages of the network. I mean, you can use them to, if you've got an intelligent agent, in principle, you can use digital twin to train that agent to be ready for that particular physical environment it's going to be encountering. So you don't have to wait for it to learn on the job, as it were. It hits the ground running with some pre-training.
Now, another thing that you keep making me think that I never thought about before. So I hope that the audience find them interesting as well as I do. Well, can you think of a digital twin to basically not replace testing, but replace some types of testing? Because instead of saying, you bring something to the lab, there's something new, I can say, okay. One way to think about it is, instead of doing the tests, is to, which is basically doing the same thing, but in a somewhat conceptually different way, is that I have a digital twin with a new product. So I have the real network that runs whatever, and I have a new product coming in, and I create a digital twin to run it and then use it for testing. Is this a way to think about it, or is it not?
Oh, absolutely. And I think you'll see, like, I think various industry bodies are defining what they see as digital twin playing a role in different parts of the next generation networks. I mean, that's really very much how the Telemanagement Forum sees digital twin. I think it's about understanding how a new service or a new capability will perform out in the wild before you've actually deployed it. And that makes sense. And it's related, I think, to what we mentioned earlier, where understanding your resilience to particular stimulus or impairments on the network. How resilient am I to certain cells going down, or what service could I offer, or how would I respond to that cell and that cell going down, or losing a transport link? That doesn't exist at the moment in the physical reality, but I'm interested in what will happen when if that does happen. How resilient can I be, and how can I respond to that? Which is a similar type of question to what happens when I roll out this new service, and what will the network do in response to that? And can I don't want to roll out a service if my subscribers are going to experience a poor quality of service, because they're going to be disappointed and I'm going to lose reputation. So yeah, these are all sorts of questions where, yes, the pure play digital twin, which is a replica of that, a digital replica of the physical system. If we deviate from that and allow those new scenarios which haven't yet been deployed to be have questions asked of them, then it's a very powerful capability.
Yeah, and as you say, well, there is this idea that you don't want to use the digital twin to duplicate what you already have, because that's kind of,
well, sometimes you do.
Yeah, but you need to have some kind of variation. So it's not just do it again. And as you do that, clearly you have to use historical data, because that's all you have, right? But you want to predict something sometimes that has not happened, because you want to know what's happened. What happens if there is way more traffic tomorrow because there is this new event. Whatever. It's just, or because you don't know, you might be, an emergency, whatever the case may be. So how do we deal with the historical data, the legacy, and increased complexity on one hand, and the fact that you need to predict the unknown? Okay, so this is like a little bit of a big question.
Yeah. Well, I mean, just to dig a little bit into the discussion just now, I mean, there's many reasons why you want to reproduce your network as it is now, and and a good example of that is to troubleshoot. So if your physical network is exhibiting adverse behavior, then troubleshooting that is going to be a priority. And troubleshooting that in the digital twin, which is a good replica of your network, could be a way to be more successful more quickly with that, or to allow an AI agent to do that diagnostics for you. So having that replica based on, well, historical data, but as close to real time as you can make it, can be very valuable in that situation. But that's a very different use case to using the digital twin to run the what if scenarios, which in service of optimization or understanding your resilience to particular scenarios.
Yeah. You mentioned the agents. That's we already talked about it. That's going to be the next podcast that we do. So stay tuned for that. But our time is almost up. But I wanted to ask you a final question. You know this, you've done it before digital twins, trying to solve similar issues. You're working on many cases. What is your advice? Because see, everybody talks about digital twins, but there is kind of, everything is kind of like, we're still I feel in the PowerPoint stage of things. You come from from applications. What is your recommendation for somebody that really needs to learn to do it? What should they be paying attention to? What should they be doing?
Very good question, thought-provoking. So I think it's not all in PowerPoint. I mean, there are good concrete examples of digital twin being used in other industries as well as telecom for solving real problems. And the human respiratory system model I mentioned earlier in my career was a digital twin of the respiratory system, and so you can solve some interesting use cases with it today. And it's about, I think it will be my advice would be to understand the different perspectives of the different industry organizations, look at the concrete examples in the literature. There's a good book on digital twin for telecommunications that was published last year. There's many papers about this, and if you've got a machine learning if you've got some experience in machine learning, maybe turn your hand to it. So look at some of there's some open source examples for digital twin which you could play with. So yes, but it's not something you can just dip into for a few days and then achieve great results. It does need some expertise. You need the data, you need to build models, and you do need to understand the use cases and how networks work. But yeah, I encourage anyone. It's a fascinating area. It's going to be, I think, central to many of the challenges that telecoms is facing today and will face in the future.
Absolutely, yeah. And I didn't mean PowerPoint. That a lot of the things you hear about are PowerPoint, but there are then people like you
Agreed.
who are actually doing it. And I think you should be more, but clearly the message that comes out, it's a little bit more, you have to do some, which if I can summarize in one sentence, you have to do some work, and then it's going to be fun. But before you get to the fun, you have to do the work. And
absolutely,
I think it's as I said, it's a really fascinating way. It's a very interesting way to think about how we improve our networks. So it's not only it's useful, but it's kind of fascinating. Anyway, Chris, thank you so much for sharing your thoughts with us. It was very inspiring talking to you.
And thank you, Monica. I've enjoyed the conversation. It's been good to think about these things and develop some ideas. Thank you.
Excellent. And thank you all for listening. And as always, you can continue following us on your favorite podcast feed under Sky Partners. Thank you so much.